Alright guys, let's continue. So this is the last part of uh, uh, a session for part 1 of chapter 8, uh, section C, so of chapter 8 part 1, right? So let's references and pointers, right? And this can be a bit confusing for people who've seen this for the first time in programming. Basically, a reference it's a name constant for an address, right? So address name as a reference can be altered after the address has been assigned, right? So but we can have an automatic dereference, which is an indirect access of a variable value without using the indirect operator symbol star, right? And without using the reference pointer ampersand, right? So let's look at how we would want to use it, right? An example of an automatic dereferencing using ampersand instead of a star, particularly gets the values of pointers, right? So for example, we can define an integer variable b, and we can get the address of b by using int ampersand a equals to b, right? So when we print a, we get the value of b, right? Not particularly the address of b, right? So statement int ampersand a here equals b, right? Basically a is declared as a reference variable, right? The compiler then assigns address of b, not the content of b itself, right? So when we say a equals to 10, right, the compiler uses the address stored in a to change the value stored in b instead, right, instead of a itself, right? So because we have the dereferences symbol here, right? Okay. So if we were to repeat the previous example using pointers instead of automatic dereference, right? So we use the star instead of the ampersand to get the values of the pointers. Then we will have to do this, right? We define the integer b, and we define the pointer a points to the address of b, right? So, and when we want to rewrite a, we will put star a equals to 10, right? So a is a pointer initialized stored at the address of b, right? So one is just automatic, the other is not really direct, right? Okay, so now a pointer a can be altered, right, to point to a different variable, whereby a reference variable a, right, cannot be altered to refer to any variable except for the one to which it was initialized, right? So this is the drawback of using a reference here. And let's look at the example here, right? So if we have two variables b and c, we have a pointer that is pointed to the address of b, and we can change the value of b, right, through a pointer a, right? Then we can assign the pointer to c and then change the address of c through a pointer of a, right? But for a reference here, right, so we have b and c, we have a automatic reference a, the reference a pointing to the value of b, right, pointing to the address of b, and we can change address of b by just using the reference here, but then we cannot reassign it to c, right? And this is basically an invalid statement, right? So once we have referenced it to point to a particular variable, we cannot reassign it, right? So the two different things, make sure you don't get them confused. Using reference as a pointer is actually not correct, right? Now, references and pointers here again. Right, let's look at this as an example. We have a, remember the ampersand is a um, uh, some 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 values here, right? A dereference sum that points to total, right? So we can see out sum equals to sum and displays the total of the sum itself, right? Which would be the total, right, in this case, right? So now we change the value of sum and we can okay, display the value of sum now, right? Or total, right? So if we change the value of sum, it will basically change the value of total, right? So the first one will print 20.5, the next one will print 18.6, right? So for the same variable, it's okay, right? If we're trying to reassign it, it cannot be done that way, right? Now, now if we consider an array, right? Now pointers are really good where we can also particularly point to arrays, right? So arrays are also just addresses in memory, right? So when we, then the question is, how do you actually access a certain array value, right? Now, in this example, if grade is a single dimensional array containing 5 integers, right, the fourth element is basically grade 3, right? So that one we know because we know how array works, right? The C++ computation of address grade, right, basically keep this into account, right? Because the address only points to the first byte. So if we are trying to access the fourth element, we have to times it by 4, right? Okay, sorry, we have to times it by 3 because we are pointing at the first element, so we have to point it at 4 bytes later, right? And let's look at this one example, right? So the address of grade 3 here would equals to the address of grade 0 plus the offset, right? So assuming we have assuming here that 1 byte, one integer is actually 4 bytes, so we have to times 3, right? Yeah, so somehow times 3 times 4 here, right? So 4 bytes times 3 for the one we are moving, right? Memory locations, right? So here is an illustration of how it works, right? So if we are trying to get the first element of grade 3, we have to we have to consider, we have to add 1 2 3 here, memory, and each integer is 4 bytes, so we have to times 4 times 3 to point to the first element of grade 3, because we start at grade 0. This will be the first address, right, that we are accessing, plus the offset, then we can access grade 3, right? So using the offset, we can basically simulate the process used by the computer to access array elements, right? And and this is a nice thing, right? Okay, so let's look at that first. Let's look at the example here, right? So suppose we have three the uh, three variables here, right? And each of it would have a the so we have a So earlier we have the example where we add the number of bytes, right? So starting address plus the bytes, right? But if we use the pointer itself, we can just add 3, for example, to move it 3 memory locations, right? In this example here, we have the pointer G pointer, not the address of grade 0, but G pointer of grade 0, right? We can access the fourth element by adding 3 to the pointer, right? And the notation goes like star G pointer plus 3, right? In bracket, right? In the bracket. So notice here, if we have the notation, this is the star G pointer star in braces, sorry, in the bracket here, G pointer plus 1, G pointer plus 2, G pointer plus 3 basically defines it where it is in a pointer, right? So don't get that confused. One is we are using the starting address, right? We are using the starting address of grade 0 and adding memory locations, right? The other is we are using the pointer itself. Okay, so if we want to address array elements, we could look through the array elements simply by having we have defined an array size, and from the array size we can loop it through by G pointer plus I, right? So it's similar to using arrays, but we are particularly going straight to the memory where the data is stored, right? Here is another method where we have a grade of array size, and then we are using the address of the variable grade plus I, right? So similar method, just different way. One, we have a pointer that points to grade. The other is that we are using the address of grade plus I particularly, right? So please try to get used to it, play around with some of the programs and try the pointer exercise, right? So this is the end of chapter 8 part 1, and I'll see you again in chapter 8 part 2, right? Thank you. Bye bye.